Hey scholars, welcome to chapter 14-5, the last section of chapter 14. And the question we're asking today is how can we use mineral resources more sustainably? Can we find substitutes? Are we going to reuse? Are we going to reduce? What are we going to do to make the use of those more long-lasting and sustainable? We can find substitutes for some scarce mineral resources. We can do it. Materials revolution, by recycling and bringing things back. We can change some things. Like nanotechnology might be an option we talked about earlier in this chapter. Silicon is a unique resource that we can use and manipulate to make look and use for different things. High strength plastics as well can be used as a substitute for different metals and minerals. The problem with that is that plastics are made from oil, so then we have to use more non-renewable resources to make those. That's a couple of the drawbacks for that one. It might not be as sturdy as well. But the substitution is not a cure-all. There are some things that literally, cannot be substituted, like platinum, industrial catalyst. We use it in a lot of different things, a lot of technologies. Chromium, essential ingredient in making stainless steel. And stainless steel we use in a ton of different things in the industry as well. So those two elements, there's no substitute for them. So there really is no substitute. So we have to do better at finding some sort of substitute for or find different resources in order to make those. We can recycle, lower environmental impact than mining if you're already taking what you've already mined and using it again. Reusing, kind of just keeping the same parts or kind of making it, reusing it again. How can we decrease our use of waste and minerals? There's a couple of different ways. Pollution and waste prevention programs, the 3P or pollution prevention pays, that's what the 3P stands for. And basically what it means is these are just different programs that allow you to help keep the waste and keep the pollution down when you're using industrial materials like minerals. Is literally trying to find ways to reuse or recycle those minerals. And then the cleaner production is literally trying to figure out how can we make these products that are having these minerals and these resources, but make them in the best eco-friendly manner that we possibly can. And so that's how we kind of help, even use our minerals and making those products more sustainably as well. There are some solutions. Again, do not waste mineral resources. Anything that was made with minerals or high-end minerals that are very, 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 very valuable. Recycle and reuse 60-80% of all mineral resources. Include the harmful environmental costs in processing of the materials in the cost of the product. That would probably drive people to use it less, or at least purchase less of that. Reduce mining subsidies. So don't be paying the companies. The government should be paying the companies to mine more if we're trying to lower the environmental price on that one. Increase subsidies for recycling and reusing. Give those fundings to the people that are finding ways to hurt the environment less, and use the materials you've already gathered in different ways and reusing them or recycling them. Redesign the manufacturing process to use less minerals and waste less minerals in the production of the products. That's a huge one. That's what we call cleaner production. Use mineral resource waste of one manufacturing process as the raw materials for another process. It's kind of how nature works, right? Nature recycles everything. We use the waste of one for the reactants or the resources for another. That's really what we should be doing too. And slowing population growth, kind of a lofty goal, but the less people you have in a population, the less resources they're going to use. One case study is kind of interesting. This is copying nature. It's called mimicking nature. It's basically where you're recycling and reusing most of the minerals and chemicals that are the byproducts of different reactions and different resources that you're trying to use. We call this resource exchange web or eco-industrial parks. And we kind of get this concept from what we call biomimicry, which is basically mimicking nature. How does nature do it? We know nature is cyclical and everything is kind of recycled as a whole, and we're trying to figure out how to better do that as human beings and in this industry as well. And so this shows you how this happens. I'm going to kind of go to a bigger, bolder picture. And we have an electrical power plant that is, it looks like it's using coal as its major energy source, and coal produces a fly ash. Well, that ash is then taken, used in making cement and cement manufacturing. There's also heat produced, and that waste heat is kind of distributed evenly to the fish farms to keep the water temperature at the right spot, the pharmaceutical plant. The waste heat goes to greenhouses to help keep the plants growing, and even some in the oil refinery. Well, there's also calcium sulfate waste that goes to wallboard factories, literally making the boards and the ceiling tiles that you see here. And so that all the waste products that are done with the electric power plant are then given off to other factories and other industries. And the same thing goes here. We have our oil refinery. There's sulfur surplus that can go to the sulfuric acid producer. There's surplus of natural gas that goes to, again, using energy to make the wallboard factory. There's so many things that you can basically take the waste from one, or the things that you're not using, and use them for something else. And that's kind of the key point in biomimicry, and also these in eco-industrial parks. That brings us to the end of chapter 14. Hope you guys enjoyed. I have. See you next time.